In our previous video, we introduced control charts. In this video, we're going to look at one control chart called the R control chart, and it has to do with the range, sample ranges of data. Our objective, we want to find the central line, the upper control limit, UCL, and the lower control limit, LCL, to create an R control chart. So what do we know? Well, we know what a control chart is. It's a line graph used to show a trend of a production characteristic over time. And we learned in the previous video that the center line is the determined mean, which ideally is the equivalent of the population mean mu, but we're going to try to match that ideal or approximate that ideal because getting the population mean rarely happens. And the upper and lower control limits, above and below the center line, are established by the use of a formula or a table. So what is an R control chart? Well, as I mentioned, an R control chart deals with sample ranges. Okay, so think R corresponds to ranges. R control chart, a control chart that plots sample ranges and is used to monitor the variation or the spread in a production process. It consists of the range values plotted sequentially over time and includes the central line, the upper control limit, and the lower control limit. You'll notice I've underlined the word range or ranges 4 times here. As you work with problems that deal with statistical process control and control charts, if you see that we're dealing with ranges, that tells you we're dealing with an R control chart. Okay? The R chart maintains a check of the dispersion or the spread of a production process. The center line or the central line for the range is defined by R bar. Okay? R bar for an R chart or the central line is the mean of the sample ranges, or sometimes it's derived from a given formula. Okay? The upper control limit and the lower control limit, again for the range, well, these are defined in terms of R bar, which is the mean range. And we're going to calculate this using an appropriate constant taken from a table of control chart factors or from a given formula. Okay, our look at statistical process control is a very surface look at this. A statistics course will deal with this in much greater detail. So we're just kind of taking a quick peek at this, and we're going to give you some formulas just to see how this looks, keeping it simple. Let's take a look at an example of this, and you'll see what I'm talking about. Example 1. In a day of production, 6 items were randomly selected and tested. Okay, so they did this. The ranges for the results for 25 days are listed below. Now again, note the word ranges. Find the central line, the upper control limit, and the lower control limit for the range. So note the word ranges and range in the problem. That tells us, if I go back up here, that we're dealing with an R control chart. Okay? As I say, other control charts, there's an X bar chart, there's a run chart, or we're looking at an R control chart. We're dealing with ranges. And here are the 25 range results for the 25 days. Let's find the central line. Well, the central line is the mean of the sample ranges, or is derived from a given formula. We weren't given a formula to find the central line. So in our case, the central line is R bar, and it's going to be the mean of the sample ranges. And these are our 25 results. So we're going to take the mean of these 25 numbers right here. I went ahead and did this on my calculator, of course, finding the mean. put them all in there into a calculator, divide by 25, or I use the mean function of a calculator, and I came up with 47.32, which tells us this is the central line. Okay, as we know from our control chart, that's the mean, that's R bar, the central line. Okay, let me switch paper here. Now we need to find the upper and lower control limits of this R chart, our control chart. In this case, we're given some information, some control chart factors. And as I spoke to here earlier, the upper and lower control limits are calculated using an appropriate constant taken from a table of control chart factors, or sometimes from a given formula. In this case, we're given a table of control chart factors. Okay, we're also told, let me get my other notes here. How do I determine the upper control limit? Well, in this case, we're told the upper control limit is equal to D4 times the central line, times R bar. So it's equal to D4 times R bar. Again, we're told this, and we want to note that we have three D4 values here. One of those is for 5 items, 6 items, or 7 items. Well, back to here, we noticed in our example that we have 6 items. So we want to say for n equals 6 because we have 6 items. Okay, so we're going to look at the row that has a 6 in it and go to D4, and our factor, our constant is 2.004. So our upper control limit is D4 for when n equals 6, which is 2.004, times R bar. Well, we previously calculated R bar, and our calculation showed us that was 47.32. And so our upper control limit is this product, and that's going to be 94.83. Okay, we're going to do the exact same thing, and I'll leave it up so you can see the control chart for our lower control limit. In this case, we're told that it is equal to D3 times R bar. Okay, and again, we're going to note that we had 6 items. Our n was equal to 6. So we want to note that for n is equal to 6 because we have 6 items. So when n is equal to 6, D3 gives us a factor of 0. So it's going to be 0 times R bar. Again, our R bar calculated was 47.32, our central line. And of course, this is pretty simple. Our lower control limit is 0. Okay, so now let's just do a brief sketch to see what this looks like. So we're looking at here, and we'll, go back to, we're going to take a look, kind of make a chart like this one that is specific to our data. Okay, so we're looking at we'll do a horizontal line here, and this is going to be our subgroup number, because that's what we're looking at. Whoops, subgroup number. And we're talking about, we'll put a 0 here, but we had 1, 2, 3, and 4, etc. As you'll recall, we had 25 of these, okay? And then on the vertical axis, this is remember, the R chart is sample ranges. So these are our sample ranges, because the R chart shows ranges, okay? And we go from 0 to 94, so I'll top this out at 100 here, so 0 to 100. Okay, so what was our R bar? Our R bar, our central line is at 47.32. So I'll put 47.32 right about here. So this is your R bar, which equals 47.32. That is the central line. The upper control limit is 94. So I'll come up to here and this is just an approximation. Our upper control limit is 94.83. Our lower control limit is 0. So that's right here. Lower control limit is equal to 0. And so we want to we'll plot our points in here. Now notice subgroup number 1, okay, was a 79. Okay, so we'll put 1 was 79. Again, I'm approximating. We'll put that point here. Number 2 was 29. So 29 is probably, let's see, it's probably a little more than halfway up there, approximately here. So we'll go like this. 3 back to here is 19. Well, 19 is obviously below 29. So we'll put that to here. 4 was 31. That's just above 29. So, and you get the idea. Here is your R control chart, and we could say etc. because we'll put 5 up to 25, and we would connect those, and we would obviously look for all of those to be within the control limits, consistent, stable. We're looking for it to be in control, statistically stable. But there's how you find the upper control limit, the lower control limit, and R bar for an R control chart.